Okay, so this is how to solve systems of equations using the substitution method. So our essential question, what we're looking for, is how do I solve a system of equation using the substitution method. Remember that a system is two or more equations with two or more variables. In our case, we're going to focus on the two, but there can be more. So there are a set of 5 steps that you should go through anytime that you're faced with a system. And you can either sub by elimination or substitution, but when you decide to use substitution, these are the steps that you need to use. So we're going to solve one equation for one of the variables. So I want an x equals or y equals equation. And then we need to substitute for that variable in the other equation. So if I set for x equals, then anywhere there's an x in the other equation, I'm going to substitute that value. We solve this new equation and then we substitute again the result from step 3 into the first equation from step 1 to find the other variable. And then when we're finished, we write them as an ordered pair x, y. So we'll take a system of equations like the one listed here, and we're going to go through those steps to find the solution. So step 1 is to look at the equations. Is there a variable isolated? And our answer is no. So then we have to choose a variable that's easiest to isolate. And in this case, it looks like it would be this equation because the y is by itself. So I can take the equation 5x plus y equals negative 13. I can subtract 5x from both sides, and I get y equals negative 5x minus 13. So substitution means that one thing equals another. So I can take all of this and put it anywhere that I have a y in my other equation. So we start out with the second equation. So that is negative 6x plus 8y equals negative 12. And right here, I'm going to substitute all of this. So that's negative 6x plus 8 times something equals negative 12. And I'm going to put in that negative 5x minus 13. So then we simplify by distributing negative 6x minus 40x minus 104 equals negative 12. Then I have to combine like terms. Negative 46x minus 104 equals negative 12. And now it's just an equation, a two-step equation. So we add 104 to both sides. Negative 46x equals 92. Divide by negative 46. And I get that x is negative 2. So there's half of my ordered pair. To be able to find y, I substitute this value into the equation with the isolated variable. In this case, the y equals equation. So I had y equals negative 5x minus 13. So negative 5 times negative 2 from up here minus 13. That's 10 minus 13. That's negative 3. So my solution should be negative 2, negative 3. Now I know it works for this equation because I just did it, so I know this one works. So now I need to substitute into the other one. And the other equation was negative 6x plus 8y equals negative 12. Negative 6 times my x is negative 2, plus 8 times negative 3 equals negative 12. 12 plus a negative 24 equals negative 12. Negative 12 is negative 12. That's a check. And that's how I know that my solution, in fact, makes both equations true. So let's do a few more examples and look at how they're set up so that you can see why substitution works best in these situations. So remember that the first step said to find one equation that was solved or to make it solved for one variable. This one's already done like that, so it makes it easier. So that means that all of this goes right here. So then I have 4x plus 4 times something equals 12. And I'm going to put negative 5x minus 1 right there. So 4x minus 20x minus 4 equals 12. That's from distributing. Combine like terms and I get negative 16x minus 4 equals 12. And I'm going to add 4 to both sides. Negative 16x equals 16. X is negative 1. So now I have one of my solutions, coordinates. So then I need to find the second one. So remember, we take this and we plug it back in the equation that was solved for one variable. So y equals negative 5 times something minus 1. That something is the negative 1 from right here. So that's 6 minus 1. Y is 5. Sorry, I added. Let's do that again. Negative 5 times negative 1 is 5, minus 1, that's 4. Y is 4. So now I have to check. I've already solved the y equation and I know that that works. So then I'm going to solve the one with two variables to make sure. So my check is, does 4 times the x plus 4 times the y equal 12? And in the x is negative 1, and in the y is positive 4. So that when I do this, negative 4 plus 16 equals 12. That's 12 equals 12, and that's correct. And so that's how I know that my solution is correct. So it's much easier when one equation is already set up to equal a variable. So when we look at the next example, you can see that the same thing is true. I already have an equation that has a variable that's isolated. So then I'm just going to plug in all of this right here. So negative 6x plus 5 times whatever y is equals 4. And y is negative 3x plus 5. Negative 6x minus 15x plus 25, that comes from distributing, equals 4. Combine like terms, negative 21 plus 21x plus 25 is 4. Subtract 25 from both sides. Negative 21x equals negative 21. X is 1. So for my solution, so far, I know that it's 1 something. So then we have to substitute this back into the equation that was isolated. So y equals negative 3 times whatever x is plus 5. Now I know that x is 1. So then y equals negative 3 plus 5. Y is 2. So then we put that up in our solution. So our solution should be 1, 2. To check that, I'm going to use the equation with two variables. Negative 6 times whatever x is plus 5 times y equals 4. I know that my x is 1 and my y is 2. So that when I simplify, negative 6 plus 10 is 4. 4 equals 4, and that's true. So again, when you have an equation that is isolated for a variable already, substitution is the best method. It is the easiest thing to move forward with. So now let's look at a couple of equations that are not set up quite that way, where we actually have to do step 1. Step 1 said you have to isolate the variable. If I try to isolate a variable here, they both have coefficients and I'll have to divide eventually. So I don't want to do that. But if I look at this one, all I have to do is to move the 6x to the other side. So this becomes y equals negative 6x plus 12. And now I have an equation that is isolated for one variable. So then I can take all of this and put it right here. So 5x plus 2 times something equals 17. I know that something needs to be the substitution value. So that's negative 6x plus 12. So 5x minus 12x plus 24 equals 17. I'm going to combine like terms. Negative 7x plus 24 equals 17. Subtract 24 from both sides. Negative 7x equals negative 7. X is 1. So then we have to take this value and plug it into here. So then I have y equals negative 6 times something plus 12. I know that the x has to go here, so that's 1. That's negative 6 plus 12. That's 6. Y is 6. So now, just to verify and make sure that I've done everything that I'm supposed to do, we're going to check by using 5 times whatever x is plus 2 times our y value should equal 17, with the idea that we are using x is 1 and y is 6 from our solution. So 5 plus 12 equals 17. 17 equals 17. That is true. And so I know that I've done my substitution and solved correctly. So far in our examples, we've always solved for y. But this next one makes it easiest to solve for x. This equation becomes x equals 6y minus 9. Notice that the sign changed because I'm going to add it to both sides, and so it would be positive, so just pay attention to your signs. But now I've solved for x. The method doesn't change, the steps don't change, we just substitute a different variable. So we start with the equation -7 times whatever x is plus 2y equals -17. And I know that this is my x value, 6y minus 9. So by distributing, I get -42y plus 63 plus 2y equals -17. I'm going to combine like terms, those are my y's. So I get -40y plus 63 equals -17. Subtract 63 from both sides, -40y equals -80. Divide by -40, y equals 2. So for my solution over here, just make sure that you put the coordinates in the right place inside the parentheses. So now let's solve our x. Remember, this has to go back up into this equation. So x equals 6 times y minus 9, except that I know that y is 2. So x equals 12 minus 3, sorry, working ahead, 12 minus 9, x equals 3. So the point should be 3, 2 is the solution to that system of equations. Remember, that means that that point is on both lines and it's where they intersect. So I've already proved that it works for this one. So then my final check is to plug it into the -7 times x plus 2 times y equals -17. I don't have enough room. So I know that the values for that, x is 3 and y is 2. So this is -21 plus 4 equals -17. -21 plus 4 is -17 equals -17. This is true. So again, that means that this point up here, the solution, is where the two lines intersect, and it's the only point that is on both lines. So that's why this works. So make sure that you go through and write step by step how to solve the equation. You can just relist the steps that I've gone through in your own words. And this is solving a system of equations using substitution.